Hello, good morning. We will continue with the third talk in this series on science and society. In the first talk, we talked about the origin of universe, formation of earth, evolution of life on this earth, and then we talked about the evolution of human beings and their migration and their reaching all parts of the world. In the second talk, we confined ourselves to South Asia, ancient South Asia, and we covered a period from 50,000 BC when the language started to evolve, and the factors that regulated the ethos of the Indian subcontinent. That being over, today, now let's move and shift gear and go to the evolution of science. That how has science evolved and in what way it is influencing the society and what is there in future of the humanity. So let's start. I'll start the screen share. Okay, so we will talk about the modern science and where are we headed in this talk. Now, this is a slide which I showed the last time, and it kind of gives you an overall view of the human evolution. You have here period before 50,000 BC when humans were not very different from, not humans, I would say, uh, our forefathers were not very different from other animals. They had not developed a neocortex, a big brain, nor was there a language, good language to communicate. It appears, it is believed that the language started evolving from 50,000 BC. Now, from 50,000 BC, thereafter we have, and now if you look at the evolution of science, the modern science, it essentially started with 17th century and it has gone up. And in between you have all this period that was responsible for, formation of the ethos of the subcontinent. Whereas this portion of the curve is responsible for all the biological instincts that we have, our genes, they all evolved here. So if you recall from the last talk that we had, India had lots of universities and they all kind of came down or were demolished by 1200 AD or 1400 AD. And after that, some kind of a dark age started in India. We had lots of invasions. There were lots of people and armies that attacked India. There was a lot of chaos all over. There were kingdoms that were fighting each other, and there were invaders that were coming and attacking and sometimes ruling over part of India. And that period, the creativity of this nation, of this subcontinent, took a dive. We were quite distracted, the whole country was. And when the real science started in 17th century, it essentially happened in Europe, and that actually left us almost untouched. That nothing like that happened in India. It happened in Europe, and we'll talk about the story of rise of science in Europe. But in India, there were very few occasional sparks that we saw. Not too many, but here are some of them in this period after the modern sciences started to evolve. We have Sir J.C. Bose of Bengal, who is considered to be the father of experimental sciences in India. And he did a lot of work on plant physiology. He evolved an instrument to measure the plant growth. He also discovered radio waves. In fact, he did it before Marconi did, but the credit did not go to him because of our patent issues and all that. But J.C. Bose was a genius ahead of his time. And he was born in Bengal, and then one of the sparks that we have in this dark times for the country. We have Sir C.V. Raman, who got the Nobel Prize in physics. In those days, in 1930, he got the Nobel Prize for discovering the Raman effect of light scattering. That is a genius that we had. Using very rudimentary equipment, he could develop the concept and should demonstrate the Raman effect, which has become very useful nowadays in a large number of fields in science and in medicine. We also had Ramanujan, a almost mystic kind of a mathematician that we had. And throughout the history of mathematics, there has been no one remotely like Srinivasan Ramanujan. And he was the one who has done tremendous work on number theory. He died young. And those of you who are interested maybe can go to Google and read about him. But these three I am putting here on this slide as some of the sparks that the country had in those times where science was not going anywhere on the subcontinent. What were the factors responsible? Factors responsible for apparent lack of interest in India and South Asia for science during this Renaissance age. It was the Renaissance of science in Europe, but we were not doing very good. And there are several reasons for that. There were constant invasions. There were waves after waves of invaders coming to India. And there were foreign rules. We were ruled by Mughals and then followed by English people. And, the country that used to be very well off before all this started actually sank into poverty. Poverty became abysmal in India. So we were totally distracted and nobody has time to think about science. The other factor which I sometimes think, which is responsible, is a basic difference between Eastern way of thinking and the Western way of thinking. It is beautifully put in a poem by Kipling, who is a Nobel laureate, and he says, "Oh, East is East and West is West, and never the twain shall meet, till earth and sky stand presently at God's great judgment seat." So he clearly announced that East is East and West is West. Their ethoses are entirely different and they will never meet. And there is some truth into that, because if I look back at the history of science and the history of the world, of the humanity, you find there is a hallmark of the Western thought, which is about exploration of the external world, which is another name for science. So the people in the West, and here I'm saying the Greeks and Romans, who were the predecessors of the Western thought, they were very interested in the exploration of external world. World around us, they wanted to know. They wanted to have knowledge about it. They want to understand how things worked and all that. And that is a good definition of science. Exploration of external world is a good definition for science. So the culture of science started in the West with Greeks and Romans about 500 BC, let's say starting from about 500 BC. And the evolution of technologies, constant innovation, this all has Greek and Roman tradition that is now has gripped the West. On the other hand, if you look at our own part of the world, we were more interested in exploration of the inner world. Okay? In fact, in Indian history of science, there are not too many people who were very keen to understand the external world. For them, the internal world was more important. So that lead to our leanings towards spiritualism, meditation, yoga, and we did have very strong traditions and skills. So we could make very good iron, we could make cotton clothes, and but we were somehow not very innovative in the external world. I have talked about mathematics and the measurement sciences and all that. These were indeed there, but here I am specifically talking about experimental sciences. Experimental sciences were kind of ignored in India for a very long time. What is the reason for that? I think there is a clue to that. And you see, the thoughts that I'm sharing with you can only be personal thoughts. There is nothing like these are gospel truth. Or what I think about it, there are two shlokas in Geeta which kind of illustrate this. Why did this happen? And I'll read these two. These are my own translations from the book that Geeta Kavya Madhuri that I referred to before also. The first one says, तीन गुणों से जनित जगत का चिंतन वेदों को करना है, इनसे ऊपर उठकर अर्जुन तुझे आत्मज्ञानी बनना है. Now what does it say? The study of this universe, which is composed of three gunas. They talk about how the matter is formed by three gunas. Is the function of Vedas. That is what is human knowledge. You see, when you gather human knowledge and you put in Vedas, that is a human gathered knowledge. So that is the function of Vedas, to accumulate that kind of knowledge. And Arjun, you have to rise above it and acquire the knowledge of the self. So what Geeta is clearly telling here is that the real important thing is the exploration of the self. That all the external world, that knowledge as contained in Vedas are one thing, but you have to rise above it and acquire the knowledge of the self. And the second one, shloka that I want to read for you, पाकर महास्रोत पानी का पोखर जो महत्व खोता है, तत्व ज्ञान पा मन वैसे ही वेदों से विरक्त होता है. As a small pond loses its significance after a vast water body is discovered, so do the Vedas lose significance once the true knowledge of the self is obtained. So I think what Lord Krishna is telling Arjuna, that above all, what is most important is to acquire the knowledge of the self. And that has been the hallmark of the subcontinent. We have had all the time seekers of the truth. And that truth is not about external world. That truth is about internal world. They want to do sakshatkar, see the God, understand the mystery of this. So all this was very important in our culture. Okay? Whereas, as I told you, in the Western cultures, these hang-ups were not there. So they concentrated themselves on the external world. And we were more concerned with the understanding of the real truth, that is the self. Now, after we became free in 1947, when English left, now the country realized after that, especially Jawaharlal Nehru, who was the first prime minister, was a great votary of science. And he made all the efforts to develop sciences, because he knew that this country cannot progress. It has to understand science, has to learn science, have to become innovative. Then only, we can compete in the modern world. It was a very good thought, and I think that made a lot of difference. Now, India has now started to learn about the science. We are a power in space technology, in atomic technologies, information technology. We are amongst the top in the world. And, we are now manufacturing everything. We know that we have excellent engineers. But you see, all these things we should always keep in mind that this is not true innovation. We have not really started to do truly innovative things. Now, if we talk about the space science, of course, we sent a satellite and we landed on moon, but all these things have been done before. It was not that we are doing it for the first time. And doing it for the first time is innovation. After that, you are copying somebody. So in fact, most of the things that now we are making progress in science, quite admirable progress, but we should not confuse it with being innovative. We are still not very innovative, and still now innovation in the science essentially comes from the West. A good example of our capabilities now is that very quickly we could develop 2 vaccines for corona. And then, it was in our own true nature, Sarve Santu Niramaya, we sent these vaccines all over the world because India always considered that the whole of the world is like a family. Vasudhaiva Kutumbakam, you may have heard. And therefore, it is our duty to help everybody. So what vaccine we developed was given to many countries. And this is really a remarkable feat for a developing country to develop your own vaccine and start immunizing your own people, not only save your own people, but to save other people of other countries also. Now let's turn back and try to understand how did Greeks and Romans function? How did they evolve there? You see, now we talk about Aristotle, and his time is about 300 BC. One of the very top thinkers, amongst the Greeks. And, he was the teacher of Alexander. And Alexander had a keen interest in studying the life forms. It's not something everybody knows. And Alexander used to provide a lot of research grants to Aristotle for his research. And in fact, Alexander's army had a standing instruction to take any life form, any sample of new life form back to Aristotle so he can study it and classify it. So this is a zeal that, a zeal to understand the world, to understand the life forms, to classify them, and if you, tremendous number of books that Aristotle wrote, and he worked in almost every field. For example, he studied the growth of an embryo inside a chick egg, and he gave very good description of the same. However, their knowledge about the world was still Earth-centric. They thought that Earth is in the center of and then all other planets, including Sun, revolves around the Earth. And now if you compare that with what is given in Rig Veda that we talked about in the last talk, they very clearly said that Earth and all other planets move around the Sun. So we were more enlightened in that way, but the zeal for studying the external world was much greater in Greeks and Romans. We should talk here about Archimedes, 300 BC. And Archimedes discovered the power of liver. That if you in the liver, you have a fulcrum, and then you from one side, if you push, the other side will rise. And depending upon the length of these, you can move very, very heavy things. And he even claimed that if you got a good fulcrum, I can even, lift the earth by using a good liver. That's what he said. He discovered this water system to pull water, to draw water from a stream by using what is now we call Archimedes, a screw. So the water is here, you turn this thing and the water comes up and you get the water. It's an invention of Archimedes. And of course, everybody has heard about the story of the concept of buoyant density. That you might recall the story that the king had made a crown, and he was suspicious that the goldsmith has mixed some baser elements, and he wanted Archimedes to find out whether it is pure gold or it is mixed with some other base metals. And this was a very difficult thing. Just imagine at that time when nobody knew what actually gold is and what are other metals, what happens if they mix. But Archimedes thought and thought about it. And that is what happens once you have a problem and you meditate on it long enough, suddenly you can find the answer. And he found the answer while he was taking a bath in a tub. And he was feeling buoyed by the water. And he gave the concept from there. He shouted Eureka, and the story is that he ran naked out of the bath tub. The concept he gave was very beautiful concept. He said that density of different matters is different. So gold will have some density and some other metals will have a different kind. Now, if you mix them, the density of the mixture will be different. And how do you find the density? You put you find the volume and divide by the weight. So you will know how many grams per milliliter or volume. Okay. So now gold will have a certain value, and let's say iron or zinc will have some other value. So if the crown does not have the density of gold, then it is a mixture. So this was a great finding coming right 2,300 years ago. The concept of point density was given by Archimedes. We can also talk about Heton of Alexandria about 10 AD. Okay. Heton was a genius, and he gave so many new concepts. I mean, he gave this formula which many of us have studied in school, how to determine the area of a triangle with sides A, B, and C. And he gave this formula, where S is actually, you add all the sides and half of that is F, S. So S into S minus A into S minus B into S minus. This is Heton's formula to calculate the area of a triangle. He also measured the diameter of the earth, circumference of the earth, and it was a very ingenious thing he did, that he had these vertical pillars he raised at different points, and by measuring their shadow, the length of their shadow, for example, if you have a pillar here, and the sunlight is coming from here, it will not cast any shadow. But if you have it in some other city, it will cast a shadow because the earth has a curvature. And by using this angle, he could calculate the circumference of the earth. And many people in that time, even in Vedas, or you know that later Aryabhatta calculated the circumferences, and they all kind of followed the same kind of a calculation. Heton almost invented steam engine in 2,000 years ago. And here is a device. Here is he is boiling some water, and the steam is going into this sphere, which is mobile, and it has two spouts. So steam comes out from here and here, and by momentum, this started rotating. The whole idea is how to convert energy into a motion, into a circular motion. That is the principle of steam engine, that you have to use steam's energy to make something move, a steam engine move. So Heton was the one who actually almost invented a steam engine so long ago. Then, you know, there are lots of examples, and if you read about the Greek and Roman history, you will find them. And here is Galen, tremendous person. He was a physiologist and a doctor. And he did extensive dissections of monkeys and pigs, because those times human dissections were not allowed. And he found out details about the blood circulation through heart, through lung, through liver, and all that, and gave very good diagrams of that. He wrote about 600 books, and he worked so much on the human physiology or the physiology of the animals that, you know, it only shows the zeal of a culture to understand the external world. So he was trying to understand how a living system functions. Now, all this happened, you can say the Greek and Roman period, 500 BC to about 500 AD. They did lots of work. They made so many different kind of innovations. They developed new techniques and all that. But there was something missing that people still did not know very basic science. For example, if you have water, what is this water? They had no idea about elements, what are elements, what are compounds, what is the nature of elements, what are things made up of, can you analyze, can you have, for example, a bird feather and find out what is this actually, what elements are there. So all those things were, even elements were not discovered by that time. Leave aside their detailed characterization, etc. So in spite of being very innovative and giving lots of techniques and thoughts, this whole phase fizzled out by about 500 AD. Okay? Otherwise, they have left a huge mark on the Western thought. If you go to Italy, you find the kind of architectural artifacts they have left, huge bridges, the water supply system of Rome, which I heard that even they are still using the same, which was made by thousands of years ago. But you see, this fizzled out. Also, the same thing happened in India. That around the same time, the momentum of thinking and intellectualism lost steam at about that time. Okay. And in India, it is being only revived now. Whereas in the Europe, the revival of science started in about 17th century. Okay. We were totally bogged down at that time, 17th century. We had totally distracted, so nothing could be done in India. But I think let's look at what happened in the West. Galileo, in 1564, he was born in 1564, he developed telescopes and he started looking at the planets. And he looked at the moon and he described and he gave many theories. He was even prosecuted by church for saying things which were considered heretic. We have Newton, born in 1642, 17th century, and he gave the concept of gravitation. He worked a lot on calculus also. And we have Kepler, who gave the law of planetary movement, the elliptical orbits in which the planets move, and all the laws that govern the movement of such planets. You see, like Newton gave the classical law of mechanics, that when things move, when you apply a force on that, you must still remember the Newton's 3 laws we all studied in the school. And the very first law says that a thing continues in a state of rest or of uniform motion until unless an external force acts on it. And then by measuring the force, you can determine what kind of a velocity will that matter acquire, etc. And in further growth of the same thing, further expansion of the idea, you have the Kepler's law of planetary movement, which has really given an entirely different picture, clarified the concepts. We can talk about great Mendel in 1822, who gave the very basic laws about inheritance. And there was no concept of genes. Forget about it. No, genes were not known at that time. But even then, he studied that characters of different plants, how are they inherited? And he gave a certain law of how these characters get assorted, and in the generation, next generation, how do they? These are kind of very revolutionary ideas which started coming around that time. One thing is very interesting in the West, that the science was not confined to people who were professional scientists. In fact, there were not that many professional scientists, but even the common public, had that internal interest to, discover things, to find out the truth. This is very different from what we have in India. In the West, for example, we have Benjamin Franklin. born in 1706. He is amongst the 8 founding fathers of America who drafted their constitution. So he was a politician, was a statesman, but he was also a scientist. You see, he discovered electricity. He discovered that when there is lightning in the sky, this actually is due to electricity. And then he did these experiments. And you see, look at the multiple dimensional personality that these people were. He also developed batteries, the concept of battery, multiple batteries and, connecting them to get electricity. He also invented spectacles. So, I mean, look, in such wide areas, a person who is otherwise a politician and a statesman worked. We can give some more examples like Michael Faraday. Michael Faraday actually was uneducated. He was a commoner. He was son of a blacksmith. And he was the one who invented the electric motor. You can't imagine that, but you see, they look at the genius of these people. And these were not really trained scientists, but there was, as I see, some inherent compulsion in the Western population to analyze things and try to innovate and find out and get new things. So similarly, he developed electric motor and he also developed electric generator in these years, about 150 years ago. And we have in the same way, Wright brothers in 1871, who developed the aeroplane, the concept of aeroplane. So they flew this airplane and, again, these people were school dropouts. So, therefore, in a particular culture, the internal compulsion, the motivation to do new things, you see in the West, that contributed to the science. Now, if you look at, we don't have time to go over the history of science in much greater details, but just look at some of the hallmarks, some of the, the important discoveries, like printing press was invented in 1470 and books could be mass produced. Before that, books were handwritten. Lots of people used to copy them and, then bind them with the handwritten manuscript. But starting from the invention of printing press, the books could be mass produced. This was a great step for the humanity in the spread of knowledge, that even common people got access to books. The steam engine was invented in 1712, and that revolutionized the transport. The steam engine and the trains started being built. Vaccination, the concept of vaccination came in 1796, and the first vaccine, which was against smallpox, and then followed by a vaccine on cholera. These are very, very important milestones, because before vaccinations became a reality, people just died. Okay, and people, you see, the great plague of Europe, in fact, wiped out 1/3 of the population of Europe. And people used to, when there were, like today, we have corona epidemic going on. But previously, last Spanish flu in 1920, when there was no vaccine for corona, or the flu, about 50 million people died. You can imagine that this concept of vaccination, and of course the modern medicine itself, antibiotics and all other things, have really made, have brought about a revolution in the health field. Photography, early 19th century, electricity in 19th century, refrigeration, late 19th century, the internal combustion engine, after which the cars were invented, 19th century. And then, quest for oil drilling and refineries, late 19th century. Anesthesia, just imagine, the people had to be operated, there was nothing to anesthetize them. The anesthesia concept came. Telephones were invented in 1876. Aeroplanes came, air conditioning, radio, rocketry, penicillin, the antibiotic, nuclear fission, so nuclear energy came. It's only 1939, so it's only about 80, 90 years before that, before us, that the nuclear fission was discovered. And of course, the internet, the contraceptive pill, about which we'll talk a little bit more later, the personal computer, and the mobile technology, information technology. So all these, you can imagine the kind of impact science has had on the society. You can't imagine the society that was there before these inventions, and it's very difficult to compare them with ours. So right now, I think human beings are relatively the most comfortable, in the most comfortable position. They can climate control, they can go anywhere they want, they have medicines, they have surgery, and all those things. So science has been a great boon in a way to improve the conditions of the humanity. Okay. However, there are side effects, and I think we'll now focus on what other things accompanied science which are proving to be a disaster. Now, we have talked about that humans are unique because of the human mind. The human mind developed with a large neocortex, and we were the first ones, we are the only ones in the animal kingdom which where we can think, we can talk, we can, convey our thoughts, we can have the knowledge given to different generations. All this is because of the human mind. Okay, but what has happened? That it appears now that the neocortical wisdom, that is the human mind, has now replaced the natural wisdom that was there before the mind, the brain developed. Before that, there was only natural wisdom. There were natural instincts. Animals were there. They had only genes. They had instincts to survive. If there was a epidemic or something, then, the whole animal, lots of them perished. There was no, getting away from that. But now after the brain has come, neocortical wisdom seems to replace now the natural wisdom, especially for the human beings. Okay. Now, humans have interfered with billions of years old process of natural selection. We have looked at the natural selection. You have mutations, and then you have the survival of the fittest, as we discovered in the first talk, the whole process of evolution. Now, we are interfering with this process now. How? Let's discuss it, but let's also first look at here, the brain, neocortex, the human mind. We all want comforts, air conditionings, automobiles, power, and everything. And then it becomes, they are mass produced, so everybody wants them, and everybody wants them. Then there's industrialization, there's mass production. And when that happens, then there's the overexploitation of natural resources. Pollution happens, acid rains, and global warming has become a big problem. All because the seeking of comforts by our mind. Okay. Now you see, nothing is even secret anymore. What is happening in America or in Europe, what kind of gadgets they have, everything we come to know immediately in our country, also throughout the world. And there is following a demand that follows, and you have to have mass production of things. But it has resulted into environmental degradation and extinction of animal and plant life, because what has happened, that as I told you, that if you look at the origin of Homo sapiens, that is the human beings, and suppose the whole evolution of life was a period of 1 year, then actually we were here only 1.5 minutes back. So we have really emerged very late, and we have suddenly risen so much, and we have changed the whole scenario of the earth. And in that process, what has happened is that we have taken a lot of space from other animal species. They don't have places. We develop cities, we cut the forest, and these animals, have to be in a more and more restricted place. And then you have, therefore, lots of species are getting extinct. taking away space from other animal species. The rapid loss of species today is estimated by some experts to be 100 to 1,000 times greater than what was the natural extinction rate before the humans evolved. All these birds, the names are here, they are all extinct now. And of course, the animal forms are getting extinct at a very high rate. That is only because the humans are taking the space and they are creating the environmental degradation, which many species cannot really sustain in those kind of conditions. Now again, come to think of it, in the natural evolution, it was a survival of the fittest. So if there were individual animals who were not really fit and who could not survive on their own, they would perish. That was a process of natural selection. This doesn't happen with humans nowadays because we have these motives. We don't want people to die. We don't want people to be weeded out. So we have developed all kinds of medicines, and so we sustain them, and even at a great cost, we develop drugs and everything. So now this is not a question of survival of the fittest. Now it is something like everybody should survive, okay, which is actually against nature. Nature had evolved a system where only the fittest people, fittest individuals would survive. But that is the kind of way we have interfered with the biology of evolution, that we now would like everybody should be sustained, not only the fittest. There is a huge issue which has come up now because of largely due to science and the new culture that has evolved, and that is the failure of fertility. And this is something we should discuss in some length. It has become a very serious issue with the humanity. Now, in a particular society, if you want to sustain the society in terms of number of individuals in it, you have to maintain a certain fertility rate. That is the average number of children born to a woman in her lifetime. That is the fertility rate. And now we know that replacement fertility rate is 2.1. That until unless each woman, produces on average 2.1 children, then the human population cannot be sustained. So if you have a fertility rate lower than 2.1, then the society will contract. If you have a fertility rate more than 2.1, then the numbers will increase. Okay, keep that basic fact in mind. So below replacement rate of fertility, a society shrinks rapidly, which is a move towards extinction. So now let's look at the fertility rate of some of the countries. This is slightly older data, but it will serve our purpose. Remember the figure 2.1. If it is less than 2.1, then the population contracts. And look at Europe. Europe has a fertility rate of 1.58. China 1.5. USA 1.9. Hong Kong 1.08. Singapore 0.8. Japan 1.39. And Saudi Arabia 2.3. So you see all these countries, except Saudi Arabia here, which is more than 2.1. You see, all these countries are losing population. They cannot sustain, they cannot maintain their population, they are declining. The world average is 2.48, so world is still growing, essentially because of the poorer countries and Africa and India, and these are still growing at a reasonable rate. So overall, the world is still growing, but all the developed countries are now contracting. Here is a typical example of Russia. It's also a bit older diagram. The Russian population peaked in about 95, 96. Okay, now it is falling rapidly. Okay, this is a extrapolation to 2050. You see the population of Russia will decline by almost 30-40%. Okay. And when in an economy or in a country, population contracts like this, the particular country, it's very difficult to survive for that country because there are no more people who are there to sustain their economics. Okay. And then similarly, another case in point is Iran. And only about a generation ago, Iran had a fertility rate of 6.5. 6.5 children per Irani woman about a generation ago. And now it has fallen so rapidly that it has become 1.7. So therefore, if you look at 2005, the distribution of the age in Iran, you see maximum number of children, maximum number of people were in the age group of 2030. But now in 2050, the younger people have really dwindling down, and it is now people are peaking at about 60, 70. Old people would be more there, young people would be lost. And this is very, very dangerous for any country. A country cannot survive if this kind of a thing happens, that you don't have young people anymore. You have only oldies, and then these people will die, and that it's very difficult to sustain the activities of a nation if the fertility goes down. In our own region, if you look at Afghanistan, the data is 2012. Afghanistan has a pretty good fertility rate. But if you look at other countries, we are almost reaching there. Maldives is already 1.79, below the replacement. Bhutan is exactly at the replacement value. Nepal 2.4, Pakistan 3, and India at 2.58. So we are still sustaining our population, even increasing a bit in South Asia. And here are the curves. You can look at the world population by level of fertility over time. You will have this slide. You can actually look at this slide for a longer period of time. You have different countries here. And this curve is for 1950-55. Like, for example, India is here. In 1950-55, the fertility rate was almost like 5.9. And in 75-80, this is the curve, and you see India has now become 4.9. And this is 2005 to 2010. India is now about 2.5. Okay, so every country is falling. And the distribution curve, which was like that about 50 years ago, is now like this. So the carry-home message here is the world population is undergoing a contraction. The human society would soon be contracting. And that is not a good news. Even within India, if you look at the states, then virtually all the southern states, even Himachal Pradesh, Maharashtra, Delhi, Karnataka, the fertility rate has fallen below 2.1. So most of the India also is now in contraction. It's only the Bihar, Madhya Pradesh, Rajasthan, UP, which used to be called Bimaru states. They are still sustaining the population growth. They are still 3.1 to 3.3 here. So actually, the growth story of India is to a large extent, it's sustained by the poorer states. They are still producing children. And therefore, our population is still growing. But you see, it is not going to go forever. And this is a very important point that I like to discuss. You see, before 1960, because in 1960, a contraceptive pill was approved. So it looks like a simple fact, but it made a revolutionary change. In the sense that before 1960, when there was no contraception available, then, in natural course, a couple will produce children. But now with the development of contraceptive pill, they can delay it, and therefore, for the first time, they can still have the pleasure of sex. For the first time, what contraceptive pill did was detached, put a cleavage between the pleasure of sex and the consequences, that is a child. So they could still have pleasure and not have child. And that was a revolutionary change in the sense that it is largely responsible for, people didn't mind for their own individual lives that, okay, we have pleasure, we will not produce children. Similarly, you have the morning after pill now, which can be used. And then, the overall effect is that you are inducing, you are actually, what results is a drop in fertility rate. Similarly, on the other side of it, the sperms. It is quite strange. The sperm count throughout the world in the males is falling rapidly. So read here, data collected from 1938 to 1990 indicates that the sperm densities in the United States have exhibited an average annual decrease of 1.5 million sperms per mil. That is a decline, or about 1.5% per year. I mean, this is a huge amount of decline. The sperms, are they vanishing? Sperms are declining at a rate of 1.5%. And in Europe, it's actually 3%. So what will happen if you have sperms below a certain critical mass? This results into infertility, that no children will be born. And this is, I've shown here a movie you may have seen, Vicky Donor, that you will require people with good sperm count. If you want to have babies, you can use their sperm. So, and the other thing is that only even the surviving sperms, the active sperms that can really fertilize is really, that proportion is also falling. So therefore, we have a decline in the quality of sperm, which is very, very rapid, almost precipitous now. And you have a decline in fertility. And therefore, what is the reason for that? And some people think that the reason could be the industrial wastes that we have. And many of these pesticides, herbicides, and worm killers, and plastic production, etc., in the industry, the byproducts that you have, or many of the drugs that you use have also a effect, like they also act like same activity as you have in estradiol, which is a female hormone. So if you have too much of that in the environment, that will obviously affect the fertility. Okay, so this is, there people have shown that lots of industrial chemicals that are used in a huge manner, they are maybe responsible, at least partially, for the fall in fertility rate. The other thing is that if you plot the female literacy rate against the birth rate, you find there is an absolute inverse correlation. That as women start getting educated, the birth rate falls precipitously. Okay. In fact, people say that education is the biggest contraceptive. And this has been shown in Indian states like Kerala, where literacy is now 100%, and they have the lowest birth rate. So I think once education increases, and especially the female education, that results into a contraceptive effect, and the number of babies born then really fall very rapidly. So this is a fact we have to live with, that female literacy results into fall in birth rate. This is a fact. It's not a commentary of any kind. But has women joining the workforce with men contributed to the decline of fertility? And that is because of many reasons. For women, there is a particular fertility window. Between this age to this age, they can bear children. Now, out of this period of time, if they spend a lot of that time in getting educated in their career and all that, then the amount of time left over for bearing the child, that falls. And obviously, that will result into a fall in fertility rate. So that's why education, because it preoccupies them away from fertility. So the age of marriage has also gone up. In the old times, marriages used to be very early. And then, a girl can be a child very early, maybe 16 years, 17 years. And if you look at your own families, our grandmothers, great-grandmothers, they bore children at very early age. But that is not possible anymore. The age of marriage has been increased. And because of education and all the career things, the decision to have a child is postponed, postponed, postponed. And participation of the women in workforce, all these things has resulted, have contributed to a marked decline in fertility. So what is the future of humanity? We may ask. Because if the fertility rate falls so rapidly, where will we be in next 100 years? See, this is a question. Now, if you look at a cockroach evolved about 350 million years ago, and it's still growing strong. And many times you will read that cockroach is so hardy an animal form, a life form, that will survive even nuclear attacks. So it is biologically a very successful species, that it has sustained itself for millions of years, hundreds of millions of years, and it is going strong. Now look at the humans. Again, remember that example, that figure that I told you, that if the evolution of life was 1 year, humans were there only for 1.5 minutes. Cockroach probably would be there for 1.5 months, but we are only for 1.5 minutes. So we have rapidly risen in this world. And if you look at the graph of human population, then especially after the advancement of science, it has really come up very, very quickly, very rapidly. And it is quite possible that it will fall equally rapidly. Now, what cockroach shows that it's not the brain that is required for survival. Cockroach has very rudimentary brain, but it survives for millions. So what is a successful study for the species from the point of view of a life form is its sustenance. And from that point of view, cockroaches have been one of the most successful species. And they don't require a brain or a higher mind. Instincts alone are sufficient. So is a evolved brain a negative factor for survival? Because we are the ones who have an evolved brain. We can think. We have a huge neocortex. And are we suffering that? Because was this a mistake on the part of nature to let us evolve a higher brain so that we stop listening to nature? So we have our own wisdom and superimpose it on the wisdom of the nature. So now if you look at, it's a very representative figure that this is a timeline. Animal species come, sustain themselves, and maybe get extinct after hundreds of millions of years. But look at the humans. We have just come so rapidly. Is it that we are going to fall equally rapidly? And then, like, a very short event on evolutionary scale, would human beings be like a small blip in a radar that a species rapidly came and rapidly destroyed itself? It occurred, it really sustained itself only for a very small time. And when I say small time, a very small time as compared to other animals who don't have brain, who are sustaining themselves only through natural instincts. So human beings, therefore, I told you that the way the fertility rate is dropping, it is a matter of, a foreseeable future where you will produce less and less children. And then, the humans cannot sustain. They might get extinct, in a relatively short period of time. So what is now our future? If we biologically, we are at a risk, but what is happening now is very interesting, is that we may be breaking free from biology. The humans, biological evolution may have ceased to operate on humans. Human mind has revolted against nature and now directs the destiny of the humanity. So it's up to our thinking, our intellect, our knowledge of the science with which we will try to sustain humanity. An explosion of scientific knowledge and expertise is underway. Human culture as we know it today, may fade away. Human race may become extinct or change into newer forms by technology. By technology. And what kind of technology? Because in science there is no taboo. They will do everything. They will clone life forms. They will design life forms. We are making humanoid robots which are looking just like humans. We are going to other planets. And, we are developing artificial intelligence in every field of our activities. And you see, look at the prediction. Artificial intelligence could be on par with human intellect by 2020, that is now. With the rapidity with which the artificial intelligence is increasing, the capabilities are increasing, they are going to pass the human intellect. And then, they are a force to reckon with. They are much, much more intelligent, than humans. Okay. Now, artificial intelligence could be on par with human intellect by 2020. After that, machine intelligence would outstrip that of humans' brain as computers and robots learn to communicate, teach, and replicate amongst themselves. This is the view from a futurologist, computer expert. And, is it possible to have marriage between human-like robots? It could happen. Because already, you see, you have people in the West, you have all kind of robots which are being developed, which are now almost indistinguishable from humans. And, they are sex robots. They will serve all the purpose that you require of them. And so they are so realistic. I mean, if you Google them, you can look at their features, etc. Look almost like humans. And, here is a forecast by David Levy. My forecast is that about 2050, the year 2050, the state of Massachusetts will be the first jurisdiction to legalize marriage between robots. So what, it looks very strange to think about, but maybe the robots are emerging as a parallel, evolved product along with humans. Like humans are actually falling off in their fertility rate, but the robots will maybe have more and more to do with the way that we live our lives. The last slide here I want to show you. Craig Venter is a living scientist. And the reason I want to show you this slide, for the first time, he seems to have created life out of that. Okay, what he did, he took out the DNA from a bacteria, and we knew the sequence of the DNA, and he synthesized the whole DNA by chemical means. So he has a chemically synthesized DNA, which is human-made. And what he did, he took out another bacteria, just killed it, removed all the things inside the bacteria, and replaced it with the DNA that he had made. And lo and behold, the things became alive. The bacterial colonies grew. So this is the first time you are actually acting like a god. You're creating a new life form. Okay? And this is mind-boggling what will happen. You can change the genes, you can make new life forms. There could be hybrid humans and robots. And so I think the future is going to be very, very strange. But the human story, as we knew for, let's say, last few, maybe 20, 30,000 years, is something which is not going to sustain. There is going to be nostalgia for simple and holistic life that we are very fast losing. So with this, I will stop this last talk. You can hear them, you can look at the slides also. And if you want to discuss something, you can always send me an email and we can discuss this further. Well, thank you very much. We'll stop here.